Hi, and welcome back to Utterly Understandable. I've got Hamish with me today. And Hamish, we've spoken a lot about optimizing product streams in terms of production yields, getting the most out of our milk. But, when it comes to what production yields are and how they influence optimization, there's still a lot that people don't quite understand and that a lot of people aren't familiar with. So would you be able to talk us through what product yields are and how they impact our optimization decisions?
Yeah, sure. Sure can, Robbie. I'm just going to share a slide that I prepared. So if you work in the dairy industry, these two charts are really key concepts to understand. What they show is the different product streams and the amount of each finished good that is produced in each stream. The top one shows the yield of finished goods per kilogram milk solids input, and the bottom one shows the same information but as a proportion of the total. If you look along the x-axis, it shows the primary stream, i.e. skim milk powder, whole milk powder, cheese, which is represented as base in the stack column, as this is what we call the first or main product you make in the production process. The other components of the stack columns then show the amount or proportion of the secondary products, i.e. AMF, buttermilk powder, WPC, and lactose. Now, the first thing people probably noticed is that powders and cheese have a higher total yield than the protein products like casein and MPC. The reason for this in powders is that you're adding lactose or permeate, which comes from the cheese and protein production, to standardise the skim milk powder and whole milk powder. And this isn't counted in the milk solids, which only looks at the fat and protein. For the cheese stream, the reason for the higher yield is that cheese has more water in it, typically 30 to 40%, than do powders or proteins, which are typically in the single digits in terms of moisture. Now, the second thing to appreciate is that the product that you get out of each stream is to a large extent fixed. I.e., if you make skim milk powder, then you'll get some fat, which can be either AMF as shown, or butter, and then either way, you get buttermilk powder. But you cannot, for instance, make skim and cheese from the same bucket of milk, or get WPC 80 when making skim, as skim contains both the casein and whey protein, but with most of the fat removed. If, on the other hand, you want WPC 80 or WPI, then you either have to make cheese or casein, as it is through this process that the whey protein is separated and can then be concentrated and dried. What is really important to realise here, though, is if you look at the bottom of the bottom graph, you only get 4 to 6% of WPC 80, or even less WPI, which, put another way, means that you get approximately 20 times the other dairy products versus your whey output. Now, if you have a large domestic market, the product streams influence what a country has available to export as excess. Why is this, you ask? Well, typically a domestic market will consume a lot of fat as either butter or cream in the food service space. And then cheese is the other main product choice, which locks in the byproducts they will have as skim milk powder, buttermilk powder, WPC 80, and WPI, and then lactose. So that kind of, in a nutshell, gives an overview of the product streams and the proportions of products that you get out when you make a particular choice around product streams. And it's really important to understand that because, in essence, you need to sell or utilise the whole bucket of milk to maximise profitability. And the product yields and the stream returns are something that's built into the logic of our platform. So, so that's it in a nutshell, Robbie.
Awesome. Thanks for that, Hamish. And thank you all for viewing. We'll see you next time.